let's have a look now at techniques for efficient virtualization. So this is how the hypervisor type 1 works when you have virtualization technology. So we have the hardware, on top of that we have the hypervisor, and then on top of that we have the guest operating system, and on top of that the user processes. Now we need to distinguish between real user and kernel mode and virtual user and kernel mode. So the real kernel mode is the one in which the hypervisor will run, because the hypervisor is operating directly on the hardware, so it can run, of course, also privileged instructions, and all the rest will be user mode from the perspective of the hypervisor. But if you look inside the guest operating system, then you can distinguish between kernel and user mode there too. In this case, we refer at the virtual modes. Now, if there is virtualization technology, you have a bitmap you can use to set the different interrupts you want to result in the hypervisor taking control. So it works as I mentioned before. Now, we said that virtualization was there even before 2005 when this technology was introduced. So how was it done before? Now we're going to have a look at that, and actually we're going to see that some previous techniques might still be efficient and used even with the presence of modern virtualization hardware. So when we started the course, I mentioned that there are these two modes, the kernel and the user mode with the bit. But in the slides, it's also mentioned that there is hardware that supports more levels of privilege. So in practice, usually you have 4 different privilege levels. These are called rings, numbered from 0 to 3 in this case. Okay. So without virtualization hardware, without virtualization at all, so when you run the operating system directly on the hardware, what it's usually done is that you use 2 of these rings, ring 0, which is the lowest one for the operating system because it can run privileged instructions. And then the highest one, you use it for the processes. So you don't really use the remaining 2. But the remaining 2 can be used when you want to use virtualization. So you can put the hypervisor at level 0. The user process, you leave it at level 4, so at ring number 3. And then you can place the operating system, the guest operating system, at ring 1. So it does not have access to all privileged instructions, which is good because we still want the hypervisor to wake up as a result of an interrupt when the guest operating system or the user process is trying to execute privileged instructions. But it allows to get more power to the operating system because it can differentiate now between who is the operating system, which can run instructions that can be run within the level of privilege of ring 1, and the user processes, the other processes that are at ring 3. Now, this does not really solve the problem of sensitive instructions. So what was done before, and it's still sometimes being used for efficiency, is basically to recompile the code, okay, so that sensitive instructions are removed. A basic block, it's a sequence of instructions that, so it's the set of following instructions that can be run by the hypervisor but that belong to the operating system. Okay, and there are a sequence of instructions that ends with a branch. Read the chapter in the book for more details about this, but basically it means it's a set of instructions that doesn't have a jump to a different function. So it's a sequential series of instructions. So what happens is that the hypervisor, before giving control to what is above the hypervisor, so the guest operating system, it scans the next block and replaces all sensitive instructions there so that it can gain control whenever these are basically executed, and thus preventing the problem of having these sensitive instructions that can behave differently between the operating system and the user process, but that would not be detected without the virtualization technology. So why do we still use this approach, even if we have hardware that supports virtualization? Because you know that everything involved in a trap or an interrupt that requires waking up a different process as a result of an invocation of a privileged function and so on, it's always a costly operation. Okay, there might be cases in which rewriting the set of instructions you are going to run performs better than actually being interrupted every time they try to access a sensitive instruction or privileged instruction. And that's why this approach is still used, and actually you can even use it for privileged instructions. So imagine that you're running a piece of code, and in this piece of code you see that you might end up disabling interrupts and then enabling them again, and maybe do this several times. If you go for standard virtualization technology, it will work, but every time you want to disable or enable, you need to wake up the hypervisor and then let the hypervisor emulate the desired behavior, taking care of actually interacting with the hardware and not messing up stuff for the other guest operating system that could be run at the same time. On the other hand, it might perform better to just translate, sort of recompile, if you want, the set of instructions you are going to execute, and maybe replace all the sensitive one or the privileged one in this case that are trying to disable the interrupts with an if statement. Okay, so you can embed the behavior of the hypervisor directly into the code you are going to run, so that instead of waking up the hypervisor each time a call to this privileged instruction is executed, you let directly the rewritten process operate as the hypervisor would do, because it's the hypervisor, who changes, who recreates the set of instructions.